Hello and welcome to Vase Projects. It's been a while, but let's get going. You know, I rewatch my own videos pretty consistently. The reason I do this is for, a documentation of my projects so I can, go and mark how I've improved or mistakes I've made so I don't remake them. But on this most recent rewatch, this is much more of a documentation of me becoming more jaded with time. Like, if you took a snapshot of each video I've made over the past 5 years and strung them together into one video, you would just see the light in my eyes go out in real time. But anyway, this is Butterbot version 3 video 1. Let's talk about it. You all saw, I put out the stepper motor testing videos, and it's pretty apparent from those that we have to move to DC. And that means a few things. First off, DC is different than steppers in how they are mechanically and how they are electrically, in very key ways. And there was a reason I wanted to do steppers because of both of them. Mechanically, they are, they run off of steps, and there is a specific number of steps per a degree rotation, which makes it easier for like position control and all that. If I need to move 30 degrees, that's like 280 steps that I can tell it to move, and it'll do that, and I know that I did that. DC motors, they just go. In fact, they go at a velocity that you tell them to go, rather than a position, so they're velocity control. You control them for a specific number of velocity for a set amount of time. Now, some of you are probably screaming at me, going, oh, but velocity is just position divided by time, so if you can control the time, you can control the position because you control the velocity. Well, it doesn't work that way. Because nothing is ever easy. You don't say, hey, move 1 millimeter per second for 10 seconds so you can move 10 millimeters. You have to control something called the duty cycle, and it's just not that simple. But we'll get there when we get there. That's a separate video. The other part is the electrical part. If you go back to those testing videos, you'll see the stepper motors, they have those little control boards. I don't have one with me, but they have LEDs going off. And how those LEDs go off is every time one or the other goes off, that's a specific pulse that it's doing. How a stepper motor works is that it gives a pulse or sometimes a half pulse, and that'll be a step or a half step. And that's how it controls what it moves. DC motors, they have a set velocity that they run off of, so it's not pulses. That's called the VCC. But then they're current driven. And basically, you tell them to go, and they will draw as much current as they need to do that, or they won't, which is stalling. So if the motor can't pull physically any more current, then it stalls, and the torque of its maximum current is called the stall torque. And there's a relationship with that called the motor constant. But that's, never in any documentation anywhere, even though it's vital for so many things. So it has to be measured, and we will be doing that. But again, that is a different video. So we're moving to DC. Let's talk about how we're doing some redesigns. First things first is the joints. The old joint that I had the stepper motor integral into the second link, which means I would have to redesign that second link every time I needed to do a different motor. I didn't have the joint separated, and that was dumb. So, we're not dumb anymore. Well, we're less dumb now. And what we're doing is we're doing a separated joint. This is the new Link 2, and it just snaps on, and it'll screw in there. I haven't put the heat set inserts, but I will. There, and how that works is I can keep this piece like I kept this piece, and just swap out the joint. Easy peasy. That will be nice. So if this DC motor here ends up being not enough, we can only reprint and redesign this single joint, and it'll work out fine. It'll make everything much more modular, and I want to apply that to all the joints going forward. And then with this design, because this interface is the exact same as this interface, I could potentially add a whole other arm here. So the modularity aspect from doing this alone has made everything a lot nicer. Other things that we have to worry about now is we now have these motor controllers. Now these are very nice, they make everything easier, but it's a lot more difficult than stepper motors alone. Stepper motors had 5 pins or 4 pins. These only have 2. One is ground, one is power. You put them into these 2 spots here that give ground and power, and how it works is that when the ground becomes the power and the power becomes the ground, it reverses direction. That's probably not the best explanation, but again, later video, better explanation. What I'll have to do to fix all the issues regarding the position stuff that I told you about earlier is I'll have to do something called discrete control. And I'll have to derive, through experimentation, the motor constant I talked about earlier and a back EMF constant, which is the motor constant but electrical. They're the same units, just different values somehow. Because again, nothing is ever easy. And from that I can develop something called the plant function in a differential equation, convert that to Laplace, and then convert that to discrete. That'll be a series of math videos, everyone's favorite. But they will be done, but again, as with everything else, later. What we are focusing on for the time being, before we get to controller design, before we get to improving the gripper design, I want to keep the same interface I had before with just the stepper on there for the time being. We gotta talk about bases and bearings. I have not done a complete base design. I want to complete the base design so I can do a basic assembly with just the DC motors and get the different joints to run with the DC motors alone. You know, not in any specific direction or specific position, just move at all. And then we can focus in on designing controllers and deriving the plant equation. All of that will seem very familiar. If you know a little bit what I'm talking about, you'll remember we did a dynamics video where we derived the differential equation for each link. It's like that, but not really, because we can't use that differential equation because we're not controlling the links. We're controlling the motor. And the motor has its whole other set of constants. So that'll be what is called the plant, which again will be explained more later. But for the time being, what we're focusing on right now is base and bearing. The full assembly of these pieces with the modular design, base and bearing. What We'll talk one more time quickly about what DC motors we have. Here it is. This DC motor I took off of the various things that I scrap. So it has no information on it, and it has no encoder either. An encoder is the kind of thing, it allows you to read back through a bunch of math where rotationally the motor is. This one has no information, it has no encoder, I just took it off something. But this one I have from an old project. It has a higher torque, and you can see that, you know, the first 2 wires are the black and red wires like the other one, and these other 4 are the encoder wire. So this will have a position encoder. So this is what I will use for the base. A more robust DC motor. And right now, the idea is to use something called bevel gears. So instead of having it go straight up, because this is long and it's much bigger than the stepper motors were, we're going to have it go in from the side. And there'll be a bevel gear here that connects at a 90-degree angle, and that will rotate the base. You want a lot of precise control over the base rotation. Because if you're off a little bit on, let's say, the gripper or the second arm, you know, if you go too far when you're spreading butter, or go too far or go too slow, you're still kind of right. But if you're off on the base rotation, then that just is magnitude. That is just increase in magnitude down the line of the bod. So yeah, the closer you are to the end, the more leeway you have. So the base piece needs to be the most correct, which is why I'm using something I didn't take off of a printer I stole from work. Anyway, that's it for now. We'll come back later with some base design CAD, and after that probably some testing. Will be a while before math, but yeah, we'll see you then. Split around. Does that work? No, it's not.